Maybe. So 5.3, that was yesterday. 5.3 is graphing these functions that we've been doing stuff with. So in this warm-up, I'm not asking you to do this with a partner. We're just going to look at it. I'll be your partner. We'll look at it together. There are 4 functions, and these are all parent functions, so there's no stretches, no shrinks, no translations.
We'll have to do that too.
Yeah. So square root of x. One thing that you should know about square roots is we cannot square root what kind of numbers?
Negative.
Negative numbers. So when you look at these graphs here, none of the x's will be negative because we can't square root a negative x. So I know it's not B and C. Now between these two, if you look carefully, the higher the power, the more straight this will be right at the 0, 0, and I just made that all smudgy, but you can see it on your paper. This one here is going to be a higher power than D. Not, I'm saying power, I mean root. It's going to have a higher root than D. So A is going to be the graph D. This one's going to be A. I'm just going to write this is square root of x. I'll give you a couple points that it goes through. There's 0, 0. It goes through 1, 1. It goes through 4, 2. It also goes through, but not on this graph, it also goes through 9, 3. What do you notice about the x value and then the y value?
They're both odd. Oh, they're roots. No, wait. It's perfect square. Sorry, there's so many stuff.
If I square x, I get y. That's what the function is. If I square root x, I get y. So up here, the next one is a cube root. Can I cube root a negative number?
Nope.
Yeah.
Yes.
You can. So the cube root's either B or C. So which one out of little b, little c, little d can be the other one you can't have negatives? Out of equation B, C, or D, which one can you not have negatives? Well, A we've already used.
C, you can.
C, because it's an even root. You can't have negatives under an even
You
root.
have positive minus. So just
You mean outside of it? Yeah, if you put the root in yourself, if you're solving an equation, you put the root in yourself, then you'd have plus minus in front of it. Okay, but for this one, it's already there. You know that x, the numbers I plug in here, can't be a negative, so this one has to be little c, which is 4th root x. All of the even roots will have just like this one arm sticking out. All of the odd roots will go both directions. So the way you can tell these apart, and it's really hard, they look very close to being the same. The way you can tell them apart is the higher root is going to have like more of a straight here at the 0, 0. It's going to be more straight. So the higher root out of these two is the graph for B. So cube root, 5th root, this one's got to be the 5th root. Sorry. And then this will be the 3rd root. Thanks. Okay. Some points. C, the picture for C for the cube root of x would be 0, 0, 1, 1, negative 1, negative 1. And then there's 2 more points that we would normally use, but they're not on this graph. They're just off. One over here would be 8, 2. And then one over here would be negative 8, negative 2. Now again, if I take the cube root of 8, I get 2. If I take the cube root of negative 8, I get negative 2. Okay. I will put those points again on a different page. Now, what I have told you since week number 1 is that we're going to do transformations the rest of the year. Some of you didn't believe me. It's coming back. It's been in every chapter. Actually, it wasn't in chapter 4, but that's only because we didn't finish chapter 4.
D goes with C.
What?
C.
No, we didn't. Okay. So, just to review, this every single one of these is a square root. It does say up here, here's the parent function, square root x. So the function is the square root. If the transformation is in the function, if it's under the square root, it's in is inside, what kind of transformation is that?
Horizontal. We're going to do the opposite.
Right, inside is horizontal, which means you do the opposite operation. And you know what? I'm going to start using a fancier word instead of opposite. I think I'm going to use the word
Reciprocal.
inverse. Sometimes it ends up being a reciprocal. But I'm going to use the word inverse operation because section 5.6 is inverses. So we'll start learning what inverses are. Inverses are like the opposite operation. Okay? So when I look at this first one and it says x plus 2, the plus 2 means what are we actually doing to the graph? We're doing a minus 2, but since it's inside, which direction are we going? Left. Left, right, left. Yeah, I know, that's why we're redoing it. And side is horizontal, so this would go left 2 units. So we just take our parent function, which you guys saw for graph, no, it was graph D. We take that function and we look, which one has moved left 2? It's A. Okay, so little a and big A, they go together. All right, look at little b. This one says x minus 2, so what does that mean is happening? Going to the right 2, which is... Is that a hiccup?
Yeah.
Do you have a cup? Okay, and then we look at little c up here. Little c has a plus 2 underneath, which we've already talked about, left 2. But it also has the minus 2, and that is not underneath. If it's not underneath, what kind of function? Vertical, and yes, it will be down. But vertical, remember, verticals never change. They just go straight up. Subtract 2 vertically, down 2. Okay, so which one is that? I mean, big B. Little c is big B. And then question D is the negative mean. Okay, but which reflection is this? In the x-axis. Thank you for saying the correct vocabulary. This is a reflect in the axis. Remember last semester when we were talking about for the first time and for the 20th axis? So Max and Ethan weren't here. Everybody take out an x-axis.
Yes.
Your x-axis, take it out.
Come on, guys, pull it out.
Pull out your
Get it out
x-axis.
of your math toolbox, guys.
Okay.
I don't have a toolbox.
Ethan. Ethan. Oh, okay. Now, put something above your x-axis. Now, we're going to reflect in the x-axis. Cameron, wakey, wakey. Reflect in the x-axis. Reflect in the x-axis. And tell me, which direction am I reflecting? Is this horizontal or vertical? This is a vertical reflection. So when we have the negative sign, not in the function, it's outside the function, that's a vertical reflection. But we say in the x-axis. Will you get it wrong if you say the wrong one?
Yes.
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 Probably yes, you will. So C and little d. All right, we are now on core concepts. Just saying, I want to write down the function points for you. I had them on the first page. I'm going to write them down again here. So for square root are x's that you can take the square root of. X you can plug into square root that you can actually take the square root of. So I'm not going to do -2, -1, 0, 1, 2. root -2? What can I square root?
1.
4.
Okay, 1's one of them. 1 is 1, the square root of 4 is 2.
0.
I can take the square root of 0, that's 0.
Wow.
Gannon.
What else? 9? Square root of 9 is
25.
Is that going to fit on my x value? Is that going to fit on my...
It sure
You
will.
should have done 16.
Oh.
0.
Put my hand on the screen.
fit on my graph as is, though.
I'm gonna punch
But
you.
maybe...
Okay.
Okay. For the cube root, values for x. Yeah. Root. We didn't pick negatives, but I also didn't pick 2.
Because 2.
Because it's not a perfect square. I mean, you can find the square root, approximated decimal, but you're not going to be necessarily using your calculator, so. All right, over here. Can I take the cube root of?
You can do
27.
1? I heard 1. I heard 27, but it's fit on my graph.
-1.
What?
Wait.
-1? What?
0.
0?
You can do
-3, -9.
8.
-9.
Cube root of 8 is 2. 9 doesn't have a cube root.
You're right.
-8.
-8.
Yeah.
Now, you can keep going, like somebody said 27. That would only be if I needed it. Because if I didn't have any transformations to change that 27, it's not going to fit on the graph. So those are my parent functions, so we're going to use those when we graph stuff. What? Oh, yeah. So now, these are really simple. There's like only one step here. There's only two steps here. This is just to remind you how to make tables. If you remember, I did not make tables this way.
You made it vertical.
Yeah, so I'm just going to write. I don't like it. I need to change my file. I made a.
Okay.
So I'm.
Went right through.
Yeah, I just wrote on top of it. I don't care. This would be points that I can square root.
This is what we're putting in the box right now.
Yes.
In my table? Yeah, I'm just not going that way.
16 because there's another box.
Well, only if we need it.
Wait, so we're not saving that for the other one?
Oh my God, Austin.
I'm just not using this because when it goes that
Well,
way.
you're saying if you were using that, those would go in that box.
If I were using it, it would be like 0, 1, 4. Yeah. Transformations. This one is under the square root. This is part of the function. So is it horizontal or vertical? Keon. Huh? Is this 1/4 horizontal or vertical?
You have a 50% chance.
Yep.
Horizontal.
Because,
Hush.
which is what I already said, yep. So if it is horizontal, do we multiply by 1/4 on the x side?
Nope.
If it's horizontal, what do we multiply by?
4.
Do the inverse operation. So instead of multiplying by 1/4, we divide by 1/4. We multiply by. Okay. So now we have 0, 4, 6. Yeah. Okay. And that's all I have. Those are my only transformations. So I cross out my old x's. 0, 4, 1. 16(2) is way out here. We just do our best to make it look good.
Beautiful.
If it asks you to graph each or graph both of the functions, then we would have the parent function, which I didn't do, probably should have, but it didn't ask me to. But sometimes it does, when you read directions. There you go.
Then you get rid of the original x.
Yeah. All right. B. So B is a cube root. I'm going to start with the cube root parent function points. So -8, -1, 0, 1, 8, which gives me -2, -1, 0, 1, 2. And I can go ahead and graph those. Parent function. I'm going to connect them with a dashed because they're not the real function. So we talk about transformations. We have a negative and we have a 3. Remember, those are two different transformations. The negative does what?
Reflection.
In the well, it's on the outside. It's on the outside. It's on the outside, so is that going to be a vertical or a horizontal? So if you this and you go up and down, that is the vertical one. In the x-axis. In the x-axis. You were people were yelling different things, so I just want to make sure everybody understands why. Okay, and then what's the 3? Is that horizontal or vertical?
Oh, that's
Mm-hmm. Vertical what?
Vertical. X-axis. Bam. Oh, done.
3 does not reflect. What does 3 do?
3.
You multiply something by 3, what's it do?
It goes tinier. Like, no, you know what I mean. Like, when you do a vertical stretch.
It is a vertical stretch, so it gets bigger. If you multiply something by 3, it gets
Yes,
bigger.
but it looks like it gets
You mean it gets skinnier?
Yeah, it gets
Only if it's a vertical stretch.
Yeah, that's what I mean. But
The
it's
horizontal stretch.
What?
Don't listen to him. He knows what he's talking about. He's not saying it very well.
Bigger, but it gets tinier.
So this is a vertical stretch by factor of 3. Put it all on the y side. I'm going to multiply everything by -3.
6.
Can I
3.
put some water on some
0. -3.
Really?
No, I didn't tell you to do it. I did not tell you to do it. Stop. Don't do it. Don't do it.
Wow. I thought you wanted me to. Didn't want me to do it.
Don't do it.
Keon, I heard it too.
Don't do it, Keon.
Alright, but if you fall asleep, Mr. Criswell didn't see.
I clearly said don't do it.
Right.
Wait, why is
It's a good question.
Whichever one
We
you want,
use the
friend.
new ones.
Yeah, with.
I-
Oh,
Follow along.
What do you need? Do you want to stand? Will that help you? Yeah. Will it help you? Okay, wait.
You're a little goober,
Since I have new y values, I scribbled out the old y values. I didn't scribble them out, but since I knew y values, those are the ones that I took over. So I can go up there and scribble them out. I'm just going to do it yet.
I was so close to not pouring water on you because Miss Criswell did not want me to.
Especially, don't put like ice down his shirt or anything like that. Oh, we didn't do domain and range yet. Oh yeah, sorry. I'm sorry. This was the part I screwed up. Think one. Domain and range. Remember, domain is which variable?
X.
Well, yeah.
It's all real.
Okay, so it's the x, and the x goes which direction?
It goes. It goes positive right.
And it's not all real numbers.
X goes left to X goes left to right. This one goes positive right only.
Stuff is set up.
So when we're looking at this, I do not have any of the graph over here. So here are being used. These are all the X's. None of them are being used.
0.
So we're going to say X is, and then it goes to the right from there. So
X is greater than or equal to 0.
You can print it out at home. Or sometime before this class. We look at the Y values. Remember, the range is down to up. Range is down to up. So how far down does it go? Well, just, and Y is greater than, equal to 0. It will keep going. It just does not go up very fast. The only time we would have something that didn't keep going is if, there was like a stopping point, like this one is a stopping point, or if it was like a parabola where it turned around and kept the direction. Like there's otherwise you can just assume it's going to keep going on forever and ever. So this one, this pink one here, how far to the left does it go? Does it go? Remember, all real numbers you can write as all real numbers, or you got symbol.
Double R.
Yeah, that
Oh, that's right. That's
fun R.
right.
And then the range, how far down and how far up does it go?
It goes.
It has an arrow,
It's going all
so it's going to go on forever. Down, it's going to go on forever up.
Forget how to do it.
So it's going to be all real numbers. If you can't make the R, then just write all real numbers.
X.
Or you could.
No, I used to be so good at it. Like, look at my. I don't know how I forget how to do it.
Okay, the next one says graph square root of x plus 1. So this is square root. My parent function points are 0, 0, 1, 1, 4, 2, 3, 9. I know that because it's just square roots. What transformation is it if we have plus 1 in function? Okay, but what's the special word?
One translation.
Invert.
Translate
Add a girl.
to the left 1 unit. So what I'm going to do, instead of making a table for this one, which you can totally make a table if you want, but instead of making a table, I'm just going to take each point and move it to the left one.
Dude, this is crazy.
Oh, she's not a dude. She's a gal.
He wasn't talking to me.
Just saying.
He's talking to you.
Yeah.
Was 9.
I'm not a dude either. I'm a.
Imagine there was.
Domain, how far to the left? How far to the left does this go?
18.
How far to the left
One.
does this go? That's not a 1. It's a
Negative
-1. So x is going to be greater than or equal to -1. How far down does it go? So y is greater than or equal to 0.
Wait, are they on the same line?
No. They're one apart.
Is it like above it a little?
Yeah, it's just, they're really close together, and I made it really thick. So
So like, do they have?
Wait, so
they'll be above each other, but they're not going to look parallel. Makes sense. Okay.
Oh, I know what you mean.
Deja, are you good or not? All right, on the next page, there's just a big box of all the transformations. If you've forgotten some of them, if you forget while you're doing the assignment, I'm not reading this to you, you've seen it a lot. And then we've got some more practice with transformations.
Wait, what was the domain for that one?
Greater than or equal to -1. X.
What? I couldn't hear you.
X greater than or equal to -1. Greater than or equal to -1. All right, so this one right here, I'm going to do without a table. You can make the table and do it with the table, but I'm going to do it without the table. This is a square root, so I'll go ahead and do 0, 0, 1, 1, 4, 2.
What was the range for the last one?
Somebody tell him the answer, please.
Y is greater than or equal to 0.
I was like, it's
excuse me.
Okay. For this one, what translations do we have? What's the minus 3 tell me?
It tells you to write.
It tells me to translate right 3, and what's the plus 4 tell me?
Dude, Anna, how do you do this?
Up
Every time I touch it, it's
4. Because it's on the outside of the square root, therefore it is same sign and vertical. So I'm just going to take each of these points and go right 3. And then what would be the domain for this one? How far to the...
X is greater than. Yeah, X is greater than or equal to 4.
Try again.
Oh, 3.
Yeah, I just said that.
30. Sorry, I can't see.
Then move closer.
No, that's not the problem. I was like looking at your graph. I was like counting. I was like,
Oh.
1, 2.
And then
But it was so funny.
range, we're looking at the pink one. The range goes all the way down to what Y value?
Was that all?
No.
No, it's 4.
Peon. No.
Oh, the new one.
The new one. And here's a hint. There's the number right there. So Y is greater than or equal to 4.
Got it.
All right, the next one is a cube root. This one I am going to use a tape for a few reasons, but mainly because there's a stretch.
There is no structure. Wait, there's a reflection.
Are you going to stay after and clean my room for detention? Then that stuff better get picked out.
It's a reflection in the.
Hold on a second. I'm writing down my parent function now.
really distracted.
Me? Well, I don't like living in a sty in a disgusting mess. That's organized. That's organized.
Dang, Austin.
That was funny though. What do you want, Josh?
Oh, sorry. You said there was a stretch, but there's actually a horizontal stretch.
There, a shrink or stretch, yeah. If there's a shrink or stretch, I'm going to use a table.
I'll tell you.
So, Josh, what do I have here? Cameron.
Oh,
What do I have?
for my transformation. For the transformation,
Yes.
you have a reflection in the y-axis.
Okay, we have a reflect. Hold on, I can't write as talk. Reflect in the y-axis, and then
Horizontal straight by a factor of 8.
okay. So everything except for your
1.
yeah horizontal shrink factor of 1/8. So the factor is like, what am I actually going to multiply the x's by? And then the actually a horizontal reflection. So I'm going to multiply everything on the x side by 1/8.
-1.
Sorry.
You did 1/8 because you gotta do the opposite, right?
Correct.
Yes. Because it's inside of the function, you have to do inverse operation, which is division instead of multiplication. Because 1/8 will make it smaller. 8 in the equation, but that makes it smaller. So I get 1/8, and I get -1. Oh, I didn't graph my parent yet. I go to graph this.
Kind of want Caitlin to talk.
No.
Yeah, we're doing
I go to graph this, and this is all I have.
works for me.
Graph this, and this is all I have.
Is that supposed to be a negative? Or is this...
Is what supposed to be negative, dear? I do have seats closer.
Wait, is that? Did you use the red and the farthest blue?
I'm just confused, because how is it?
You're saying a lot of like it or that, and I don't know what you're looking at, so I don't know how to answer your question. Well, do you want me to answer it?
I do.
I don't know what her question is.
What?
Okay.
No,
So when I look at these 5 points, I feel like it's not going to be very accurate. So this is where I would add on maybe a value. I'm going to add in an x value that I can easily multiply by an 8 and get a nice answer. What? What? We're doing day 1. So what could I multiply 1/8 by that is also a perfect cube?
27.
27 times 1/8 is not a nice number. Let's think better.
8.
I already did 8.
Oh.
5.
No. 24.
Not a perfect cube.
Oh, wait.
Oh, 16.
Survey says.
Not a perfect cube.
Not. Oh.
Nice.
27?
She said 27 is too big.
I did not say it's too big. I said 27 times 1/8 is going to give me a yucky number I didn't want to graph. You can use 27. I just didn't want to do a fraction. What?
What is it?
Times not cube. 216.
4?
273. Oh, I get it. I get it.
Or
Oh yeah, that works.
I'm going to use 64,
That works. That's
which has a cube. And when I multiply it by negative 1/8, I get so negative 8/4. And then if I did the if I did the negative 64, I would get the positive. So that one would be over here.
Wait, where did you get
She did 64 times 1.
Please stop. Please stop. So again, we are using transformations and using transformations and using transformations. What's our domain and range for this?
All real
Domain
numbers.
and range.
All real numbers.
For cube roots, it's all real numbers.
And fifth, all the odds.
All the odds will always be all real numbers. Yep. Okay, I'm going to skip student practice number 2. We're just going to look at mathematics. This one is a function e of d, 5 square root d. This function right here approximates the number of seconds it takes a dropped object on Earth. So if you drop something, how long does it take to hit the ground? The function m of d equals 1.6 times e of d approximates the number of seconds it takes a dropped object to fall d feet on Mars. Write a rule for m. And then how long does it take the dropped object to fall 64 feet on Mars? We have 2 things to answer. Yes.
So you said for cube roots, will always be all real.
Yep. Yep. Okay, so the Mars function is 1.6 multiplied by the Earth function. So that's what we're saying right here, 1.6 times Earth function. Well, it is given to us, thank goodness. So I'm going to say 1.6 times the Earth function. Here's my Earth function.
So times 0.25 square root of d.
Mm-hmm. So it's kind of like multiplying 16 times 25 cents. Kind of. Do you know how many 25 cents times 16?
It's a load of quarters.
It is. It's 16 quarters. How many make $1?
4 whole.
So what's this going to give?
$4.
Okay, but it's not 16, it's 1.6. So what do you think it is?
1.4.
I don't know what 0.6
Oh, it's 0.4. Just kidding.
I was just doing a little bit of mental math there. Okay, so this is the first question. What's the rule for m? Do you see how we plugged in Earth into the m function and just simplified?
I don't.
Yeah, well,
I do know.
you know
Just
what we did?
We substituted what Earth is in that spot. Okay, then the second says, how long will it take the dropped object to fall 64 feet on Mars? So now we're going to do the Mars function for 64.
equals Earth, right?
Equals 0.4 square root 64. D, make it 64.
Square root of 64 is
So I get 0.4. What is the square root of 64?
8.
So 4 times 8 is 32. So 0.4 times 8 is 0.2. And what was I actually finding?
There was a time.
Time. So what are my units? Seconds, right?
Equals?
Okay. Is that going to fall faster or slower on Earth?
slower, faster.
How can we find out?
Don't tell me that.
Plug it back in, plug it into
This Mars.
plug it into Earth's equation.
Yeah, let's do E of 64, which is right times square root 64. So 0.25 times 8, 1/4 of 8 is
8 divided by 4 is 2.
2 seconds.
Yeah.
Who has stronger gravity?
Me.
Not you, out of Mars and Earth. Who has stronger?
Mars got 3.2.
I say we.
That's not the gravity,
Will
Preston.
not go.
This is how long it takes an object to fall.
Gravity is Earth.
So won't a stronger gravity pull it faster?
No.
Earth has a stronger gravity.
He's on Kansas.
You will need some graph paper for, which I have to hand.
No.
Talking about the other word that you just said on it. Okay, I'm going to hand you some graph paper. The assignment is written on the board, but is also on Canvas, and it is due tomorrow.